Black holes are one of the most fascinating and mysterious objects in the universe. Black holes are regions in space where the gravitational pull is so strong that nothing, not even light, can escape. They form when a massive star dies and its core collapses under its own weight. They are invisible to the naked eye and are formed by collapsed stars, with extremely strong gravitational fields. This makes them extremely difficult to detect and study. Yet they continue to capture the imagination of scientists and the public alike. In this article, we will look at what we know about black holes, the unanswered questions that still stump astronomers, and recent breakthroughs in black hole research. Scientists have been studying black holes for decades and have made significant progress in understanding their properties. We know that there are different types of black holes, including stellar, intermediate, and supermassive black holes. But how do black holes form? Black holes form when a massive star runs out of fuel and its core collapses under its own weight. The core becomes so dense that it creates a gravitational pull so strong that even light cannot escape. As I said, there are three types of black holes: stellar, intermediate, and supermassive black holes. Stellar black holes are formed by the collapse of a single massive star, while intermediate black holes are formed by the merger of several smaller black holes. Supermassive black holes are found at the centers of galaxies and are believed to have formed from the merger of several intermediate black holes. There is such a hole at the center of the Milky Way, Sagittarius A. It has a mass equal to about 4 million suns and could hold several million Earths. You're probably all wondering what's inside a black hole. No one knows for sure. Supposedly, a black hole consists of two main parts. There is the event horizon, a boundary in space-time through which matter and light can only pass inward. Nothing, not even light, can leave the event horizon and cannot be detected. To a distant observer, clocks near a black hole will appear slower than those farther away. This is called gravitational time dilation. It causes an object falling into the hole to appear to slow down as it approaches the event horizon. Any light emitted by the object appears redder and dimmer. Eventually, the falling object disappears completely. At the center, as described in the general theory of relativity, is a gravitational singularity, a region where the curvature of space-time becomes infinite. For a non-rotating black hole, this region takes the form of a single point. For a rotating black hole, it blurs to form a ring shape. The singular region has infinite density. The distance from the center to the event horizon is called the Schwarzschild radius. Observers falling into the hole will inevitably fall into the singularity. Before this happens, they will be torn apart by the growing tidal forces in a process sometimes called spaghettification or the noodle effect. The point is that the gravitational force created by the singularity will be much stronger at one end of the body than at the other. If someone fell into a black hole with their feet forward, the gravity at their feet would be much stronger than at their head, causing the person to stretch vertically. Taking a peek inside a black hole is impossible. At least, so far, scientists haven't figured out how to do it, but they have come up with many theories about what might lie beyond the event horizon. Number 1. The rotating vortex theory. According to one theory, the matter in a black hole is in a state of a very rapidly rotating vortex. An object that has passed through the event horizon increases greatly in length and begins to rotate around the center, just like spaghetti in a pot. For this reason, scientists have given such a process the name spaghettification. Number 2. The theory of the information paradox. According to the works of Stephen Hawking, radiation is the only phenomenon that manages to escape from a black hole. From this, we can conclude that black holes disappear over time. They cannot disappear, as a black hole is an indestructible object, so the holes simply go away. So, Hawking decided that from a black hole, the object does return to our world in the form of radiation. However, this does not mean that if a cosmonaut, for example, falls into the hole, after a while he will return alive and unharmed. Hawking's theory is about the possibility of preservation of quantum numbers, charges of elementary particles and transitions of matter into antimatter. Number 3. The theory that nothing will happen. This theory sounds like the most optimistic, but unfortunately it's only an assumption that doesn't have much evidence. Scientists assume that the impossibility of going beyond the event horizon applies only to light, and that the supermassive gravitational object itself is located very far beyond the event horizon itself. Number 4. The white hole theory. This theory was born from the question, if light cannot go beyond the black hole, then what happens to it inside it? So, scientists do not rule out that inside black holes there is not absolute darkness, but quite real universes, which, unlike ours, are there in a compressed form. Number 5. Alternate space theory. This theory was also put forth by Stephen Hawking. He suggested that the very state of singularity in a black hole could be a very real alternative space-time universe. If you fantasize according to this theory, you can get to other worlds. But unfortunately, there is no way to return from there. In April 2019, the Event Horizon Telescope, EHT, collaboration obtained the first direct image of a black hole. The image, which showed the shadow of a supermassive black hole at the center of the Messier 87 galaxy, was a breakthrough in black hole research. Another significant advance in black hole research is the detection of gravitational waves. In 2015, the Laser Interferometer Gravitational Wave Observatory, LIGO, first detected gravitational waves resulting from the collision of two black holes. Since then, many black hole mergers have been discovered, giving scientists new insights into the behavior and properties of black holes. New telescopes and technologies are also being developed to better observe and study black holes. The upcoming James Webb Space Telescope, scheduled for launch in 2021, studies black holes and their surroundings in unprecedented detail. Since we have touched upon the topic of black holes, let's talk about so-called wormholes, which are closely related to black holes. Wormholes are so-called narrow bridges that are formed in space huge or infinite areas of existing space. As a rule, they have a connection with large inaccuracies of space and time. Near the smallest part of the mole hole is a region called the neck. It is a two-dimensional surface, the area of which is extremely small. Scientists have suggested that the nearest point of entry into the alleged wormhole may be near the supermassive black hole Sagittarius A, which in turn is located in the center of the Milky Way galaxy. A person caught in such a wormhole would experience an acceleration of about 20 g, unpleasant but not fatal. But there are some practical limitations to this theory. For example, the mole hole must be extremely clean, that is, without random particles. In addition, the process of forming such a wormhole has not yet been described. And finally, although traveling through such a tunnel through the galaxy would take less than a second, from the point of view of those outside the wormhole, your journey would last tens of thousands of years. Thank you for watching. Like and subscribe to the channel. See you soon. Bye.